circles, and trigonometry. In this video, you will look at the relationship between circles and trigonometry. Let's get started by looking at some terminology. To start, we will draw an x-axis and a y-axis coordinate system. It should look like this. The initial arm is the ray or the arm of an angle in standard position that is on the positive x-axis. This means that you're going to draw the initial line from which you're drawing the angle along the x-axis. All angles that we will be using start on the x-axis. This is the beginning location. It's indicated on the diagram by the green arrow. Now, the next term we want to look at is the terminal arm. The ray or arm of an angle in standard position that rotates about the origin is called the terminal arm. This arm represents the ending arm or ray or position of the angle we are representing. For example, our diagram shows a rotation of 60 degrees. We start at the initial arm, we rotate to the terminal arm for a measure of 60 degrees. Note, positive angles are a rotation in a counterclockwise direction. Negative angles rotate in a clockwise direction. This information will be useful soon. A terminal point. The point on the initial arm can be labeled point A with the x value r and the y value 0. The terminal point, then, is the point on the circle that results from forming a given angle in standard position. This is the angle of rotation. This point will be on the terminal arm and the circle that can be drawn around this point. This point can be labeled P with coordinates x, y. This is your terminal point. This point will have an x component and a y component. The x and y intersect at a 90-degree angle. These x and y values can be used to determine the length of the terminal arm. We will use the value r or the letter r to indicate this radius value. Keep in mind the radius is the distance from the center of the circle to the outside of the circle. An angle in standard position will have an x component, a y component, and we have the r component indicating the radius. Since a 90-degree angle is formed where x and y meet, we can use the Pythagorean theorem to find the length of r, given the values x and y. This will give us the formula then, r squared is equal to x squared plus y squared. Now, how can we solve a problem using this information? Here is a sample problem. Find the radius of the circle given point P at 8, 6. The measure of the angle in standard position for this terminal point P at 8 and 6. And then we want to state the primary trigonometric ratios for this angle in exact form. Here is the solution. Note, this should be done on graph paper if you have any available. Number 1, start by making the sketch. To do this, make the X and Y coordinate system. Plot the given coordinate P at point 8, 6 on this system. X is 8, Y is 6, and so we have point P at 8, 6. Now, draw the terminal arm and label it R. Add the reference angle. Using the Pythagorean theorem, find the value of R. R squared is equal to X squared plus Y squared. Or we could say R is equal to the square root of X squared plus Y squared. Substitute in our numbers. We would get the square root of 8 squared plus 6 squared, which would give us the final answer of 10. So we know R is of length 10. Find the measure of the angle theta. You are given the X value is Y divided by X. Now, we can substitute in our values. Tan theta is equal to 6 divided by 8, which on our calculator, we would use second function, tan, bracket, 6 divided by 8, bracket, and we could get the answer 39.9 degrees rounded to 1 decimal. You should check to make sure that I'm correct. And now, here are the 3 primary trigonometric ratios in exact form and also to the lowest common terms. Sine theta is opposite over hypotenuse, which is Y over R. So we will get 6 over 10, which reduces to 3 over 5 by cross-canceling. Cos theta is adjacent divided by hypotenuse, which is X over R. Substituting into the equation, cos theta is 8 over 10, which is equal to 4 over 5, again through cross-canceling. And tan theta is opposite divided by adjacent, which is Y over X. Substituting in, tan theta is 6 over 8, which reduces to 3 over 4. Now we have the primary trig ratios. Now, here is another question. Let's try it. Find the radius of the circle whose terminal point is P at -5 and 12. The measure of the angle in standard position for the terminal point P, -5 and 12, and then we want to state the primary trigonometric ratios for this angle in exact form. This is almost the same as the sample problem number 1, but there are a few little differences. Let's explore. Now, let's make the sketch of the angle in standard position. Make the X and Y coordinate system. Plot the coordinate P at negative 5, 12 on this system. X is negative 5. Note the direction. Y is 12. Plot the point. Draw the terminal arm. Label it R. Add the reference angle, theta. Now, use the Pythagorean theorem to find the value of R. Remember the formula, R squared is equal to X squared plus Y squared. R is the square root of X squared plus Y squared. R is the square root of negative 5 squared plus 12 squared, which equals 13. Now, find the measure of theta. You are given the x value, which is adjacent to the angle. X is equal to negative 5. You are given the value of y, which is opposite to the angle. Y is 12. We will use then the trig ratio tan theta is opposite divided by adjacent, which is equal to y divided by x. Now, we're going to substitute in, so the tan theta is equal to y divided by x, which is 12 divided by negative 5, which is negative 12 over 5. If you use your second function, tan, on your calculator, theta rounded to 1 decimal is negative 67.4. But what does the negative mean? We haven't seen that before. What it means is that it's in the second quadrant, so we need to do one more step before we find the angle in standard position. Remember that the angle in standard position starts at the x-axis. Since the angle is in the second quadrant, we must subtract this measure that we found in our calculation from 180 degrees. Theta equals 180 degrees minus 67.4 degrees. So theta is 112.6 degrees, the angle in standard position. Now, sine theta is opposite over hypotenuse, which is y over r. Sine theta is y over r, which is 12 over 13. Cos theta is adjacent over hypotenuse, which is x over r. Cos theta, then, is negative 5 over 13. Tan is opposite over adjacent, which is y over x. Tan theta is also negative 5 over 12. There are some rules that you need to follow when working with circles in trigonometry. In the second quadrant, sine has a positive value. Cos and tan have a negative value. To find the angle in standard position, use the formula 180 degrees minus the absolute value of the angle measure calculated. This means if it's negative, you will put it into positive format. In the third quadrant, tan has a positive value. Sine and cos have a negative value. To find the angle in standard position, use the formula 180 degrees plus the absolute value of the angle measure calculated. In the fourth quadrant, cos has a positive value. Sine and tan have a negative value. To find the angle in standard position, use the formula 360 degrees minus the absolute value of the angle measure calculated. There's a four-letter word to help us remember the signs of the trigonometric ratios. The four-letter word is C, meaning cos is positive, sine and tan are negative. A, all are positive. S, sine is positive, cos and tan are negative. T, tan is positive, sine and cos are negative. This is called the cast rule. Very important to remember. Now we're going to look at a special type of circle called the unit circle. The unit circle, as I just said, is a special kind of circle. The radius of the circle is 1 unit, and it is centered at the origin. This special circle allows us to do many different types of calculations. Here is an example. Sample problem number 3. A terminal point P, x, y, because we don't know the coordinates, is on the unit circle, such that it forms a 120-degree angle in standard position. Find the coordinates of point P. How do the coordinates of a point on the unit circle relate to trigonometric ratios? Here is the sketch. We have an x and y coordinate system. We have a circle with radius 1. We have a point on the circle with coordinates x, y, and we have a terminal arm. The measure of theta is shown to be 120 degrees in standard position. Draw the sketch. We've done that. Determine r. When we're using the unit circle, we remember the rule of Pythagoras. X squared plus y squared is r squared. But in this situation, we know that r is 1, and 1 squared is 1. X squared plus y squared, therefore, is 1. Now, sine theta is y over r. The sine of 120 degrees is y over 1. So the sine of 120 is equal to y. On your calculator, you would find that to be y at 0.866. That seems easy. Now, let's try it with cos. Cos theta is x over r. The cos of 120 degrees is x over 1. So the cos of 120 degrees is x, and x is negative 0.5. How do the coordinates of a point on the unit circle relate to trigonometric ratios? The ordered pair of any point on the unit circle is the cosine x, the sine y of any given angle in standard position. So cos theta is x over r, which is x over 1, which is x. That's easy to remember. Sine theta is y over r, which is y over 1, which is y. This gives us an important equation that we can use when solving trigonometric identities. Since the equation of the unit circle is x squared plus y squared is 1, then cos theta squared plus sine theta squared is equal to 1. Now, let's put this wealth of knowledge you have just learned to work by completing your quiz and your project. Best of luck!